Hey guys, welcome to another lesson. So today, another nice question in the nice question series. Today's question comes from the advanced syllabus from James Ruse 2022 trial paper. So the topic that today's question is in is trigonometry. There's a bit of exponential logs and a bit of calculus. So a blend of a blend of topics that make up the one question. Now, I believe it's the last question in the Ruse paper for the advanced paper for 2022. So, like it's not super hard, but it's nice, right? Hence why it's part of the series. So before we dive in, guys, as always, if you haven't already done so, please like the video, subscribe to our channel, and tell your friends. Guys, let's dive in. So, all right, James Ruse 2022 has this question. Let's check it out. So diagram below shows graph of y equals ln x squared. Okay, x squared and 0. There are 3 points that lie on the curve, right? And now the next line is really important. There's a shaded part, right? There's P, Q, R, there's a triangle, and the area of that triangle is maximum, right? When the tangent at R is parallel to the line through to PQ, okay? Okay. Show that R has these coordinates to have a maximum area. So basically when the tangent, so let me just draw a line. If I drew a line, oops, not a line, I drew a line from P to Q, I copy that line and made it a tangent there, right? So R gives a maximum area when the tangent at R is the same gradient as PQ, right? That's really what the first, that green highlight up here is about. Yep. In fact, you know what? Just to make it super clear, I'll just highlight the pink section referring to the pink line. Yep. Okay, what else do I have to do here? So find R, okay. Find the size of angle PQR. So that's PQR, that's this one here. So green pen. So if I had there, yeah, to find theta there, that's theta. Okay, hence find the maximum area. Okay. Find maximum area there. Okay, cool. Now, finding maximum area feels like it's an optimization maximum minimum question where I have to find it's not, right? It's actually much easier than that. But okay, let's start this question and check it out. So part A. So part A, I just have to find the gradient of PQ and then basically find maybe the equation of the tangent at of the curve and then basically try to find R and equate it somehow. Right? So let's check it out. So maybe let R have coordinates x, y for now. Don't know whether that's useful or not. Might be. Right. So I need to find the gradient of PQ first, right? Yeah, let's see what we're talking about. So now P, where were the coordinates here? So let's label it. Label it here. So Q had the coordinates of E and 2. P, I'd write over here. P has the coordinates of 1 and 0. Okay, cool. Very easy. So gradient y2 minus y1 x2 minus x1. Yeah, let me see, y2, yep, okay. So that's like 2 over e minus 1. Yeah, pretty straightforward. Now, to find the gradient here, right, because I probably need to equate it, right? So I need to differentiate. So if f of x is ln of x squared, now f dash x, to differentiate ln functions, you basically put the function side down here and the derivative upstairs. So the x cancels at 2 on x. Yeah, so if I equate that, that would hopefully set these two equal to each other, that one and that one, right? Because then that would hopefully let me find the value of x. So 2 over x minus e minus 1. E is a constant, right? So 2 on x, so then e minus 1 equals to x. X equals to what's, well, that is x, right? So x equals to e minus 1. Now, because there's an x value and a y value, that's the x value, right? I need to sub that into the original equation. So to find the y value, so once you find x, you go therefore y equals to ln of e minus 1 squared, right? And that's your y value. So got x, got y, and that's exactly what they're looking for, I think. Quick look, e minus 1, yeah, perfect. So therefore, r equals 2, e minus 1, ln, now they use square brackets, I'll use that too. E minus 1 squared. Done. Yeah, put a box around that. So, I mean, wasn't that hard? It's just nice, right? It's just nice, yeah? That's part A. Right, now part B, let's see what they want me to do. They want me to find the area of that theta. Now, what I can do, right? A couple of ways of doing that. You can use a cosine rule, but because I'm already dealing with gradients, right? What you can do, right? Let me show you diagrammatically what I'm thinking. Yeah. So in part B, now if you have, let's say, I have a number plane, right? And there's like, what's it look like? Something like that, and I'm trying to find the theta here, right? What I can do is find the big theta and then minus small theta. So if I go, that's alpha and that's beta, I can go alpha minus beta, right? And use like, because we're talking about gradients, I can use angle of inclination, right? So angle of inclination is tan theta equals the gradient, yeah? Angle of inclination, yeah? Make sure you guys know that. So in this case, right, I can find in this diagram here, if I let that there be alpha, that there be beta, right? Because I have the coordinates, I can actually find those two, right? So let's have a go. So actually I need to find the gradient of PR first, right? So I'll go gradient of PR equals 2 now, R and P. So R I just found, so it's Y2, which is ln of E minus 1 squared minus Y1, which is it 1? No, 0. 1, 0 over x2, what was it? E minus 1 minus 1. So E minus 1 minus 1. That looks like ln plus 2. Yep. Check that. That looks fine, right? So therefore, tan of alpha equals to the gradient, right? So let me just see. So ln E minus 1. Now this is just a constant, right? Just an ugly constant. So what I'm going to try to do is punch it in the calculator. So grab yourself a calculator. Let's try to do so. Inverse tan, fraction ln, now E minus 1 squared, and then just gotta be careful. I don't know how the order of operation on the calculator works with logs, so maybe I just put an extra bracket there just in case. Yeah, and then on the bottom, E minus 2. Okay, I got 56 degrees, is that right? Yep, perfect. 56 degrees and what's that, 26 minutes? Okay, I'm going to store that in memory. All right, that's a gradient of alpha. And now if I go gradient, I know that the gradient of the line PQ, I've found that, haven't I? That's up here. Is 2 on E minus 1. Gradient of PQ equals to 2 on E minus 1. So therefore, tan beta is equal to 2 on E minus 1. So if I'm going to shift tan or inverse tan that. So inverse tan of 2 on E minus 1. Looks like it's 49, is it? 49.20. So therefore, beta is 49 degrees 20. Perfect. And then you take a difference, right? So therefore, theta is alpha minus beta on your calculator. You do 7 degrees. What's it say? Nearest degree. Okay, 7 degrees. Yeah. That's my answer. Guys, angle of inclination twice, right? And then take a difference. Nothing too hard about that, right? And then lastly, find the maximum area. Now, I already know that coordinate r gives maximum area, so I just need to find the area, right? Using trigonometry, a half, two sides times sine of it included an angle. So I just need to find the distances between PR and PQ, right? So I will shuffle over slightly here. Just give me a little bit of space. Okay. Should be enough space. Okay. So move over a bit. So for part C, area of, or maybe max area, right? To be more specific, area of triangle PQR equals to a half times the distance, right, of PR times the distance of PQ times sine of the angle I literally just found. So sine angle was it RPQ. Yeah, so actually I'll save the RPQ in memory. Saved in memory. Okay, great. So that equals to, now, should I do it all? I can do it all in the same calculation. So that equals a half times square root. Yeah. Now PR will be x2 minus x1 squared, right? So PR will be e minus 1. So that's e minus 2. Whoa. Squared plus, and y2 minus y1 now. R is just ln e minus 1 squared on the calculator, right? Times square root. Now PQ, what's P and Q coordinates? PQ, so e minus 1, 2 minus 0. Okay, e minus 1 and 2 minus 0 is 2 squared, and then multiply that by sine. Yeah, 7 degrees, whatever, but I'll put in the exact value. So I'll put which we know is 7 degrees. So I think you just punch it in the calculator. Yeah. So if you punch all that in the calculator, let me just check the working. I think that's perfect. Perfect. Yep. If you punch it in the calculator, I believe you should get 0.21 units squared. Yeah. Guys, how's that? So nice question, right? A little bit different. I mean, that uses like trig, exponential, and logs, and also calculus, right? Not your usual. Whenever you see the word maximum area, tends to be, if especially in an advanced paper, tends to be optimization. This one isn't, right? So don't fall for that trap. It's not enough marks for optimization. Normally, optimization has 3 marks, right? This only has 2. So, but that's not the giveaway. The giveaway is when you go through the actual pieces, you're not actually finding anything that maximizes or minimizes in the usual sense of optimization. So guys, hopefully that question was nice. Like the video, subscribe to the channel, and I'll see you at the next one. Thank you very much.